And thank you all for attending. We are NOA Sistemas. NOA is a system integrator based out of Aguascalientes State in Mexico. Just to give you a heads up, Aguascalientes is the geographic central state of Mexico, about 500 kilometers north of Mexico City, about 500 or 600 kilometers south of Monterrey, which is the two biggest landmarks that you might know of outside of the country. Right now, we're going to do a brief introduction of ourselves, myself and Marthos, as the company NOA. We'll let you know how we did a system for a customer in the broad spectrum, and we will be happy to receive any feedback, any questions, or any comments that you want to do on the QA sessions. Fernando Cisneros, myself, I've been in automation over 30 years, mostly in robotic automation and mostly in difficult processes for robotics, welding, painting, a lot of material handling as well. But I've been around automation and around industry for 30 plus years now. I have a bachelor in electrical engineering in 1993 from ITESM in Mexico. And I've been overall automation responsible for several lines and several integrations starting on the year 2000. With me is Marthos Angulo. I'm going to introduce him right now. There he is. Marthos is a mechatronics engineer. He has a master in science in optomechatronics, and he is the main developer on the system that we're going to talk about here. That's why I invited him as co-host, so he can explain a little bit on the technical details on what we did, how we did it, and also make the presentation clear for you in that sense as well. NOA, who is NOA Sistemas? NOA is an automation integration company, basically aiming to small and mid-sized projects, and also looking for high-risk or difficult-to-do processes. We are not a company that likes to do the same old everywhere. We want to do an advantage to the customer on hard-to-do processes, on high-risk processes, on high-risk clients. We founded NOA in 2013, and we have been working with several companies in Mexico, both Mexican corporation and external corporates from the US, from England, from Germany, from France. Right now, last year we did systems adding about 30 robots and about 3 or 4 dedicated machines. Here are some pictures of some items that we have done in the past, and that is our core business, basically high-risk processes, full automation, and turnkey systems. Why did NOA go to CODESYS? We were doing all the traditional PLC automation for a number of years. We did all the traditional controls for a number of years. And when we were exposed to CODESYS, we looked at the opportunity to put in the framework, the CODESYS framework, in service for our customers. Basically, getting the CODESYS tool set, getting the ever-changing requirements from our customers, and getting all the benefits of the CODESYS system working for our customers. Right now, CODESYS is the stable tool set that we use and promote with our customers on every project. And we also service customers that have a more traditional and standardized PLC or control structures. We can do that, but we have been using CODESYS as a great tool for us and for our customers. And the scaling of it has been a great value for many of our customers now that have embedded CODESYS into their lives. Today's talk is a project that we built for a customer here in Mexico. It's an automotive assembly. It's a safety part for pickup trucks. So you can see there is a container, high pressure container for brakes and suspension on pickup trucks. The assemblies and sub-assemblies, this is the requirements that we had from our customer. Assemblies and sub-assemblies needed to be quality verified before and after any operation, meaning that we need to make sure that we have good parts and good sub-assemblies into the operation, and then good parts and sub-assemblies out of the operation, plus real-time database tracking on a customer server, and real-time measurement as well on all the individual parts and sub-assemblies. NOA implemented this system with 19 robots. These are ABB robots per customer preference. And these robots control the production of the assemblies, with 7 operators feeding individual small parts to the system for a total of 17 individual parts assembled in several operations to conform the full assembly. We implemented CODESYS-based controls in this line to comply with management, visualization, interfacing, and reporting, and the overall functionality that the customer was looking for. It was a great all-in-one tool that we could offer to our customer instead of having multiple different platforms trying to interact with each other to get everything going. Also, another challenge was that other equipments were set up on the line, very specific niche equipments from other vendors that we integrated also into the CODESYS controls to have a full line control set up and the functionality that our customer and their customer were expecting. Today, the end user is producing 3 shifts, 6 days a week, an average of 26 parts per hour. The required rate that the customer has is 30 parts per hour, and the line was designed to do about 35 parts per hour. We're on the ramp up still, and we still have some geometry challenges, as well as some floating production requirements. So this is what we needed to solve in the field. This is the line that we needed to set up for our customer. How did we do this? We did this is a general layout of the system in which we show the operations being done on the line, starting with operation 40 all the way up through operation 130. The operators interact with the system in operation 40, setting up the first part, 50, 60, 70, 90, and 100. All the operations are transferred in and out with robots and verified for quality control, for measurements with robots with no human interaction whatsoever. This line starts in operation 40, and operation 130 picks up a pallet full of good parts with a database tracking data on each one of them. And all the data from the processes that were done on every operation are also stored in the database. So every part coming out of the line has the full history of the line, of the processes, the parameters, and the times that it ran, with measurements on individual parts, on sub-assemblies, and full assembly. Right now, I'm gonna give the mic to Marthos. I will be helping on the English side if something gets stuck, so he can explain some of the detail that we did on this line. Here you go, Marthos.
Thank you, Fernando. So we're going to explain the PLC layout that we use to develop this project. In the first layer of the network, we use a CODESYS PLC from Berghoff, and we use also the newest version of CODESYS available right now to develop this project. This main PLC, it's the one that when the final user can choose if the complete line is working in automatic mode, manual mode, or semi-automatic mode. Also, this one is have a direct line or a direct connection with the user server to store all the data from the complete line production. In the second layer of control, we have 3 CODESYS PLC also. It's the same version that the main one, but those ones are viable or are the ones that control the welding process in the 3 lines, in the 3 cells productions for welding with robots also. That would be the main process for welding machines, but also the main PLC and the second one are viable to control the movement of the parts in the line with I don't know how to say that, pick
and place, material handling.
Okay. Also, we have several PLCs from other vendors that are working in this project also. Those ones could be like Siemens, Delta, Schneider, or even other Berghoff PLCs in this line. The first one PLC will be in the beginning of the line, and that's a Schneider PLC. Also, we have another PLC, Berghoff, in the middle of the line to control a cleaning process. And in the final line, we have a Delta, 2 Delta PLCs, and finally a Siemens PLC, which controls another devices in this final one. We use interface like Ethernet IP, EtherCAT, but also we use variable networks to share information between the PLCs. Okay, about the quality control tracking layout, we have several devices available in this network, this line. We have Wembler laser profilers that shares information for the main PLC by Ethernet IP. These laser profiles give us the state of the and
It's the measurement of the part.
measurement.
So they full measure the individual parts coming into the line. And at the end of the day, have a go, no go signal as well to the main PLC.
Okay, thank you, Fernando. Every piece in the line that the user entered to the production line are trackable by a QR reader, by several QR reader that you can see in the slide. And that also shares information for the main PLC and the Welding's PLC by Ethernet IP. Once we have the quality state of each PLC, that stage it's attached to a QR code, and that data are stored in the database of the user. We also have Wengler laser profiler mount on a Discover motion servo that are used for the same purpose. Also, we have weld measurements by Guillen's profiler that shares information for the main PLC, also by Ethernet IP. All those data are shared between the Welding's PLC and also to the main PLC to control the complete line of production. That information, it's very important for the user to have an histogram and maybe control how the production
the variation of the production
production.
and the yield rate of the tanks.
Thank you. Also, we have another devices not described in this slide, like IO models, another device that the user want to be installed in the line. Has CODESYS, and the PLCs that we are using are very flexible to integrate different kind of devices. So that's why we use that we use CODESYS to make this integration in a better way. Okay. Also, we had a lot of robots, like 13 robots available in this project, used specific to move the pieces between one operation and another. Also, on those robots are mounted some kind of cameras for do the quality control previously described in this presentation. All robots communicate by Ethernet IP to CODESYS, to the PLC CODESYS, but also those robots have mounted on the structure of them another devices like pneumatic manifolds or IOS models and cameras, as I said before. Those robots move the pieces between one operation and another, and those are controlled by the welding PLC's control, and also by the main PLC if the operation is in every operation.
Here, a quick note on the communications. I mean, with the communications, we were able to blend in all the PLCs from the vendors and collect all the data that needed to go on the database on the line with the main CODESYS system going into line. So this is something that we couldn't have done with a branded PLC and without like 25 different licenses to get it going. So that was a very good advantage that we could set up for our customer going forward.
Okay, about the HMI layout, we have some HMI available also by Bergov in the line. The first one would be the main PLC, which have an HMI. But in this HMI, you can also see the orders control process of the PLCs. We have another in the second layer HMI, the operation of welding process also have an HMI each of them. But you can see in the first operation what's happening also in the second operation if the user wants. Also, we have another vendor HMI where we can see also what's happening in those PLCs. That's because every visualization is developed by WebVisu, so we can see what's happening in the complete line in everywhere. We also have another vendor HMIs, and we can do that. That's because they're not developed user policies, but that's a great opportunity to us to develop that kind of systems. As you can see in this slide, there are a lot of HMIs available in the complete line. So the user can see what's happening at the beginning of the line without being right there. They can see that information even in the final line of the process. And also you can see the data if you're connected to the network by another protocol like Ethernet IP.
Yeah, one requirement that the customer had was to have a full visibility of the line, of the process, and every part of the line. So WebVisu development helped us a lot getting the right information on the right station, but also being able to see other operations, to see other controls within the line without having to physically go out there and look them over. Basically, what the customer requires us to do on the remote connection is to look at production rates hourly, is to look at failures, is to look at alarm logs, and that was provided swiftly by the WebVisu interfaces that we were able to do here. Also, all the auxiliary WebVisu screens that you see there are screens mainly from the measurement equipment, from the laser measurement programs that are running, measuring, and showing on screen the results of the measurements on individual parts as well on subassemblies and the welding measurements. But they can also switch into the WebVisu interface to look at other operations within the line. So basically this visualization scope on the line lets our customers see everything that they need to see from one place. It gets somehow a little confusing because there is too much going on, but they are kind of leaning towards simplifying a little bit on the initial requirements in order not to confuse themselves with all the issues that need to be seen on the line. Next, Marcos, I will let you explain a little bit on the resources here and the screens.
Well, we have a lot of devices available in this project. So you can see the three Ethernet IP, have a lot of devices uh, interacting with the main PLC. Also, we have a Ethercat and other protocols like variable network. But the PLC, the technical specification of the PLC let us do this kind of development. There are a lot of devices, and the PLC runs perfectly without any problem. Also, we have several screens, as you can see in the slide on this screen, in the right side of the slide. And the PLC works perfectly. The final users interact with the system without any problem and see like I don't know, several devices like scanners, security scanners, or the security state of every security interlock, doors, light screens, and also security scanners or e-stops, emergency stops. That kind of visualization let us develop this kind of project with in a better way for the final user.
At the end of the day, when this development, this line was built in about 3 months' time, all the basic structure of it. We spent about 3 months as well on the on-site debugging and putting everything to work finally. And the line is working with our customers. They have seen CODESYS is a great tool for automation, great tool for scalability, and also a great tool to have all this stuff going on at the same time and controlled at the same time without many issues. That's basically our presentation for today. This is just a scratch on this field application. I'm guessing